Hi, let us see this problem. We are given a singly linked list. We need to find middle of it. Let's see this example. We have 5 nodes in this linked list and middle of these 5 nodes is 20. So we need to print 20. Let's see this example. In this example, we have even nodes. So we have 2 middle nodes. In such cases, we need to print the second middle. So our output is going to be 15. In this example, we have a single node. So single node itself is the middle. When you have empty linked list, your output is going to be empty. We don't need to print anything because there is no middle element. When you have 2 nodes in a linked list, you need to print the second node of the linked list. Now please pause this video and try to write down a function that takes head of a linked list as an argument and prints the middle of the linked list. Let us first talk about the naive solution. Here is C++ implementation of the naive solution and here we have Java implementation. The idea of this naive solution is simple. First we count how many nodes this linked list has. For example, this linked list has 5 nodes and this linked list has 6 nodes. Once we have the count, we run a loop from 0 to count by 2 to move the current from head to the middle node exactly. For example, count is 5 here, count by 2 is going to be 2. So we are going to move this current pointer or reference that begins from the head 2 times. First time when we move, it will come to 20. Next time when we move, it comes to 30, which is the middle node. Let's see this example. Here we have the count as 6. We need to move our current reference or pointer from head node 3 times. First time when we move, it will come to 20. Next time when we move, it will come to 30. And next time when we move, it comes to 40, which is our expected output. So this is the idea. First, count how many nodes this linked list has. Once you have the count, run a loop, count by 2 times, and move your current pointer or reference from head to the appropriate middle node. And at the end, print whatever current node has. Let's now talk about the corner cases. How are we handling the corner cases? When your linked list is empty, head is null. This case has been handled here explicitly. When linked list has single node, what will happen? We will have the count as 1 after this loop and count by 2 will be 0. So this loop will not run at all. We are expecting I to be smaller than 0. So our current will stay on head and we will print the head's data. Let's now see the case when we have 2 nodes in the linked list. Count will be 2. We will run this loop only once. So it will move to the second node and we will print the second node's data. This solution requires 2 traversals of the linked list. Now please pause this video and think of a solution that finds the middle of a linked list using only 1 traversal of the linked list. Let us now talk about the efficient solution. This solution requires 1 traversal and is based on idea of slow and fast pointers or references. We maintain 2 pointers or references, pointers in C++ and references in Java, slow and fast. Slow moves 1 node at a time and fast moves 2 nodes at a time. So when fast reaches end, slow reaches middle. So we get the approach, but we have to be careful for handling both even and odd nodes linked list. Let's do these examples. Let's understand the approach with these examples. We have even nodes in this linked list. Slow and fast, both are initially at the head. Slow moves 1 node at a time, slow comes here. And fast moves 2 nodes at a time, so fast comes here. Now slow again moves 1 node at a time, so slow comes here. And fast moves 2 nodes at a time, so fast comes to null. And this is the point where you want to stop. This is your expected output for this linked list of 4 nodes. So when did you stop? When fast became null. Let's now see the odd nodes example. Slow and fast both are here. Slow moves 1 node at a time and fast moves 2 nodes at a time. Now slow moves 1 node at a time and fast moves 2 nodes at a time. And this is the point where you want your algorithm to stop because this is the middle node of linked list. So now please pause this video and try to write down a program that gives you the correct middle in all cases. Here are C++ and Java implementations of the approach. Before we take a look at these implementations, let's do these examples again. Let's do this example of 4 nodes. What happened here was slow and fast both started from head. Fast moved 2 nodes at a time and slow moved 1 node at a time. And when fast became null, our slow was at the middle node. And in case of odd nodes, again they both started from the same point. When fast reached the last node, slow reached the middle node. So what we do in implementation is we maintain 2 pointers or references, slow and fast. Both of them begin from head, and we move both of them this way. Fast moves 2 nodes at a time and slow moves 1 node at a time. When fast becomes null or fast next become null, we stop. And when we come out of the loop, we print the slow data, right? Because when fast becomes null or fast next become nulls, at that point, slow is referring to the middle node. This is what we have done in these implementations. This is C++ and this is Java implementation. We have initialized slow and fast as head. Then we have run a loop. Inside this loop, we are checking for this condition while fast is not null and fast next not null. Please note that fast not equal to null condition is required even when we have all input linked lists as odd node linked lists. Because we should never access null arrow next or null dot next, right? That would cause problems. So fast not equal to null, it helps us in all the cases. It also ensures that null next is never accessed. So we have talked about a solution that finds the middle of a linked list in one traversal of it.